In the silent, frozen expanses of the upper stratosphere, a new battleground is being defined.
The 21st century's strategic calculus is rapidly evolving beyond traditional notions of air superiority.
Driven by the dual specters of hypersonic weapons and the increasing militarization of low Earth orbit.
It is within this new, terrifying paradigm that Russia has conceived its most ambitious aerospace project.
The Mikoyan PAKDP, or Prospective Aviation Complex for Long-Range Interception.
Known colloquially as the MiG-41, this conceptual sixth-generation aircraft
is not merely a successor to the legendary MiG-31 Foxhound.
It represents a philosophical and technological leap.
Intended to counter the foundational pillars of Western military power. This is not another multi-role fighter. It is envisioned as a weapon of strategic dominance, a silver bullet. Designed to hunt threats that are, as of today, considered uninterceptable.
Thereby redrawing the very boundaries of aerial warfare and aerospace defense.
To comprehend the sheer audacity of the MiG-41, one must first understand the legacy it seeks to inherit. The Mikoyan-Gurevich MiG-31 was a marvel of its time.
A colossal, brutish interceptor forged in the crucible of the Cold War.
Its purpose was not dogfighting. It was the defense of the Soviet Union's vast, indefensible 12,000-mile northern border.
From swarms of American B-52 and B-1 bombers.
With a top speed of Mach 2.83 and a service ceiling over 67,000 feet.
The MiG-31 was a missile truck capable of look-down, shoot-down engagements,
creating an aerial shield where ground-based missiles could not.
Its continued relevance has been demonstrated in the 2020s. Where its ability to launch the long-range R-37M air-to-air missile from high altitude and speed
has posed a significant threat, forcing adversaries to operate under a constant virtual cap.
But even the Foxhound, with all its upgrades, is a 20th century solution to a 20th century problem.
The contemporary threat matrix is profoundly different.
The new bombers are not subsonic aircraft, but hypersonic glide vehicles, traveling at over Mach 5.
And intercontinental missiles that release maneuvering re-entry vehicles.
The new reconnaissance threats are not SR-71s,
but constellations of thousands of low Earth orbit satellites, like Starlink,
that provide persistent, real-time command, control, communications, intelligence, surveillance, and reconnaissance to battlefield units.
These threats exist in a domain the MiG-31 cannot touch. The near-space region, between 65,000 and 330,000 feet.
a zone too high for traditional air defenses and too low for orbital anti-satellite systems.
The United States' next-generation air dominance program and China's own sixth-generation ambitions.
Meanwhile, are heavily focused on networking, artificial intelligence, and all-aspect stealth.
Russia, facing economic constraints and a different set of strategic vulnerabilities, has chosen a different path.
Instead of a networked system of systems like NJAD, which relies on swarms of loyal wingman drones.
Russia's PAK-DP concept appears to be a return to its historical strength.
The creation of a single, exquisite platform with unmatched physical performance.
The MiG-41's purpose is not to fight a war of attrition, but to hold the West's most advanced strategic assets, hypersonic missiles and orbital satellites, at risk.
It is a strategic deterrent in the form of an interceptor.
A machine designed to re-establish the primacy of the defense in an age of seemingly unstoppable offense.
This project is a gamble of colossal proportions, one that bets Russia's aerospace future on the belief that speed, altitude, and power can, once again, checkmate.
A technologically advanced and numerically superior FOE.
The performance parameters publicly associated with the MiG-41 project are staggering, bordering on the mythical.
Have publicly stated the aircraft's intended speed to be in the range of Mach 4.0 to Mach 4.3.
Mach 4.3, potentially Mach 5.
With some more speculative reports suggesting capabilities extending to Mach 5.
To put this in perspective, this is significantly faster than the sustained cruise of the legendary SR-71 Blackbird.
This is not merely an incremental increase in speed. It is a fundamental transition from supersonic to hypersonic flight.
A domain that introduces engineering challenges of an entirely different magnitude.
At these velocities, the aircraft is no longer simply flying through the air. It is in a state of constant, violent collision with it,
generating plasma and a thermal thicket where friction heats the aircraft's skin.
Point to temperatures that can melt conventional titanium and aluminum.
The successful development of such a machine hinges on a trinity of interdependent technological breakthroughs.
Propulsion, material science, and advanced aerodynamics.
The heart of the challenge lies in the engine.
No conventional turbojet can function at such speeds.
The MiG-31's massive Soloviev D-30 F6 engines reach their thermal and mechanical limits around Mach 3. At speeds beyond Mach 3.5, the air entering the compressor is so hot that it would melt the turbine blades before combustion even occurs.
To achieve Mach 4 and beyond, the MiG-41 requires a combined cycle engine, a hybrid system that adapts to different flight regimes.
The most likely candidate is a turbine-based combined cycle, often referred to as a turbo-ramjet.
This system would operate as a conventional.
Then, as the aircraft accelerates past Mach 2.5 or 3.0,
a sophisticated system of ducts and variable geometry inlets would divert the incoming airflow
around the core turbojet machinery. The bypassed air mixes with fuel and ignites in a simple, long chamber, feeding it directly into a ramjet/scramjet-style combustion chamber.
In this mode, the entire engine acts as a simple ram-powered duct, producing massive thrust with incredible.
While the SR-71's Pratt & Whitney J58 engine was a primitive, mechanically complex version of this.
Distinction. A true TBCC for a Mach 4 plus fighter is an order of magnitude more complex.
This propulsion system is useless, however, if the airframe itself disintegrates from the heat.
At Mach 4.3,
Leading-edge temperatures on the wings and nose cone can exceed 1,000 degrees Celsius. The source text's mention of titanium alloys and carbon composites is a significant understatement.
This thermal load requires next-generation materials, such as ceramic matrix composites and new oxide-dispersed titanium alloys.
Materials that are lightweight, like carbon fiber, but have the heat resistance of ceramics.
Furthermore, the aircraft would require a complex active cooling system, not dissimilar to the SR-71's,
which circulated its own specialized JP-7 fuel behind the skin as a heat sink.
The MiG-41 would require an even more advanced regenerative cooling system,
likely using its own fuel to manage the immense thermal stress across the entire airframe.
Described as having a sharply pointed nose, large air intakes, and swept delta wings.
The large, variable geometry intakes are critical for managing the transition of supersonic airflow,
or managing the shock waves required for stable ramjet combustion.
The sharply swept delta wing is a classic high-speed design, balancing the need for lift at high altitudes with the imperative to minimize wave drag.
Every surface I can Go ahead, Lewis.
The engineering challenge is thus not simply to build a fast engine, but to create a holistic, integrated system
where the airframe, inlets, and engine function as one single hypersonic machine.
A feat of materials science and fluid dynamics that remains at the absolute zenith.
The precision required for the fuselage ALU is unprecedented. We're talking about the future
of modern aerospace engineering.
The MiG-41's design philosophy represents a radical departure from the 21st century's dominant stealth paradigm.
Western fifth-generation aircraft, such as the F-22 Raptor and F-35 Lightning II, are low observable platforms.
They are designed to be all aspects stealthy, primarily in the X-band spectrum, and achieve survivability by operating.
The MiG-41, as a Mach 4 interceptor, cannot be a stealth aircraft in this same sense.
The very physics of its mission, the colossal infrared signature, make it a thermodynamic inevitability.
Therefore, Russia appears to be redefining stealth and survivability on its own terms, based on a different triad: speed, altitude, and...
The project's survivability is not based on hiding, but on an engagement model,
where the interceptor detects, targets, and destroys its objective from a range and speed that makes retaliation physically impossible.
The sensor array integrates directly with the quantum entanglement source.
This strategy is entirely dependent on a revolutionary sensor suite.
The source text's claim of a quantum radar is, on the surface, the most speculative.
Quantum illumination is a real, if nascent, field of physics. It theorizes a system that uses pairs of entangled photons.
One stream is kept in the aircraft, while the other is beamed out. When the signal photons reflect off a target, they return and are...
Because of their quantum entanglement, the system can differentiate these returning photons from all background noise and jamming with near-perfect certainty.
In theory, this would make it possible to detect low observable targets that would be lost in the clutter of a conventional radar, while the engineering challenge is monumental and likely decades away.
Its inclusion in the PAK-DP's conceptual framework signals a clear research and development trajectory against VLO targets.
More practically, the MiG-41's true counter-stealth capability will likely come from next-generation technologies. The low-band detection is critical.
Stealth aircraft are tuned to defeat high-frequency X-band radars. They are less stealthy against low-frequency search radars.
These low-band systems, however, lack the resolution for a weapons-grade lock.
The MiG-41's concept of operations would likely be a multi-static engagement.
A network of ground-based, low-band radars would detect the presence of a stealth fighter and then cue the MiG-41's own sensors.
The interceptor would then use its massive speed to close the distance and employ
A stealth fighter's skin, designed to absorb radar, heats up from air friction just like any other, making it
This entire engagement, lasting mere minutes from detection to kill, is far too fast for a human pilot to manage alone.
Target destroyed. The claim of an advanced glass cockpit system with artificial intelligence integration is thus not a luxury, but a core requirement.
Solution suggested. Data link fused. Engine transition complete.
The AI would be responsible for fusing desing data.
It would manage the complex engine transitions, navigate at 1,000 miles per hour, and even suggest tactical maneuvers and targeting solutions.
To protect this data flow, the concept of quantum communication is floated as a theoretically unhackable, jam-proof data link.
In sum, the MiG-41 is conceived as an apex predator, its stealth achieved not by being invisible,
but by being the first to see, the first to understand, and the first to strike, all from a position of overwhelming kinematic advantage.
The third pillar of the MiG-41's performance envelope, its operational altitude, is perhaps its most strategically significant. The Sourcetex and Russian officials have consistently linked the project to near-space operations, with a service ceiling projected to be as high as 100,000 feet.
This altitude is not arbitrary. It places the MiG-41 in a desolate, unexplored stratum of the atmosphere.
Far above the 60,000-foot ceiling of fifth-generation fighters and most existing surface-to-air missiles.
yet below the Kármán line that defines the beginning of outer space.
This high frontier capability fundamentally redefines the aircraft's mission, transforming it from a simple interceptor into
The decision to engineer a platform for this domain is a direct response to the two most disruptive threats of the 20th.
First, the MiG-41 is being positioned as the world's first dedicated interceptor for hypersonic weapons.
Hypersonic glide vehicles are designed to be unstoppable by conventional means.
They fly at Mach 5+ in the upper atmosphere, below traditional anti-ballistic missile systems, but above ground-based and airborne interceptors.
The MiG-41's 100,000-foot ceiling gives it a unique look-down kinematic advantage.
By flying at a similar altitude and at hypersonic speeds itself, it is the only platform theoretically capable of getting into the basket.
Against a maneuvering HGV in its mid-course phase.
This defensive mission is paramount to Russia's national security, as it offers a potential shield against prompt global strike weapons.
Second, and more offensively, the 100,000-foot altitude makes the MiG-41 a potent anti-satellite weapon.
Yes. Modern net warfare is critically dependent on a vast architecture of... This network, while powerful, is also a fragile, single point of failure.
From its near-space perch, the MiG-41 would serve as an air launch platform for a new generation of direct-ascent ASAT missiles.
Flying high above the densest part of the atmosphere, the interceptor would loft a missile on a trajectory to destroy critical LED
signal lost.
The psychological and strategic deterrent of holding an adversary's entire C3ISR network at risk is immeasurable.
This capability aligns perfectly with Russia's A2AD doctrine, creating a bubble where enemy forces are deaf, dumb, and blind.
The engineering challenges of near-space operation are of course immense. At 100,000 feet, the
traditional aerodynamic control surfaces are ineffective, requiring the aircraft to use reaction control system thrusters for maneuvering.
Thanks to the RCS thrusters on the nose and wings, the MiG-41 is capable of maneuvering much like a spacecraft.
Furthermore, air-breathing engines, even ramjets, struggle in the oxygen-starved environment.
Suggesting the propulsion system might need a rocket-based or oxidizer-injected mode for its final ascent and maneuvering.
requiring a full space-capable life support system.
The pursuit of this high frontier is a calculated, strategic move to seize,
placing the MiG-41 at the critical intersection of aeronautics and astronautics. The kinematic supremacy of the MiG-41, its speed and altitude, is ultimately a means to an end.
To serve as the ideal launch platform for a new generation of standoff weaponry. At Mach 4 and 100,000 feet, a missile launch imparts an enormous amount of initial launch energy,
dramatically extending its range and no escape zone compared to a launch from a conventional, slower, lower-flying fighter.
To maintain its aerodynamic and low observable profile, this entire arsenal must be carried in internal weapons bays, as any external pylons would create catastrophic drag and heat stress at hypersonic speeds. The envisioned weapons suite falls into three distinct, revolutionary categories.
Advanced long-range interceptor missiles, air-launched hypersonic strike weapons, and defensive directed energy systems.
The baseline weapon will be an evolution of the Vimpel R-37M, the missile that has already proven its lethality with the MiG-31.
the R-37M is a colossal weapon. I think next kill.
Its purpose is to destroy high-value force multipliers such as AWACS, electronic warfare aircraft, and refueling tanks.
Launched from a MiG-41, the R-37M's effective range would be extended even further, creating a death zone hundreds of miles wide.
More revolutionary, however, is the MPKR-DP concept. This is a weapon born from the challenge of hitting agile hypersonic targets.
Instead of a single large warhead, the MPKR-DP is envisioned as a carrier missile that dispenses a volley of smaller, guided submunitions.
This shotgun blast approach dramatically increases the kill probability against a fast, maneuvering target like an HGV.
The second category transforms the MiG-41 from a defensive interceptor into a strategic offensive asset.
Its speed and altitude make it the perfect first stage for air-launched hypersonic strike weapons.
The Kinzhal is an air-launched ballistic missile that can strike ground and naval targets at ranges up to 2,000 kilometers.
By launching it from a platform that is already traveling at Mach 4 and 100,000 feet.
The MiG-41 could impart so much energy to the weapon that its range and terminal velocity would be significantly increased,
making it a formidable anti-carrier or bunker buster weapon, all while the launch platform remains in a near-invulnerable sanctuary.
Finally, the most futuristic element of its arsenal is the mention of laser-based weapons.
While an offensive laser is likely beyond capabilities, a defensive application is more plausible.
The project may incorporate a Dazzler laser system, a high-intensity turreted laser designed to blind the infrared,
effectively acting as a high-tech flare system.
This would provide a critical last-ditch defense against any weapon that manages to get a lock on the hypersonic interceptor.
In totality, the MiG-41's arsenal is not just an upgrade. It's a new class of long-range, high-speed effectors.
Designed to win an engagement before the enemy is even aware it is being targeted.
The Mikoyan PAC-DP, or MiG-41, exists today as a powerful and unsettling concept. An amalgam of ambitious specifications, strategic imperatives, and profound technological skepticism.
In its final analysis, the project must be viewed through two distinct lenses.
First, as a statement of Russia's divergent philosophy, and second, as a tangible engineering program facing immense, perhaps insurmountable hurdles.
This dual identity, as both a mythical paper tiger and a logical strategic response, is what makes it one of...
It is a machine that could change the global balance, even if it never flies in numbers, simply by forcing a Western response.
The core of the MiG-41's identity is its stark contrast to the American sixth-generation approach. the Next Generation Air Dominance Program.
The philosophy is one of distributed lethality, data fusion, and AI-driven networking.
Survivability is achieved through stealth and by spreading sensors and weapons across multiple platforms.
Russia's PAKDP, in contrast, reflects a silver bullet philosophy.
It is a singular, exquisite platform that achieves dominance through raw, unmatched physical performance.
It is a strategic choice born of necessity, a recognition that Russia cannot compete with the US in a system of systems arms race.
But can potentially create an asymmetric counter by developing a single platform that negates the West's primary advantages too.
This brings the analysis to the crucial question of feasibility. The official timelines are viewed by
Russia's aerospace industry has struggled significantly with the mass production of its fifth-generation aircraft, the Su-57.
Plagued by delays, economic sanctions, and technological hurdles, the Su-57 has been produced in only small, boutique numbers.
The logical and critical question follows. If the Russian economy cannot support the mass production of a fifth-generation aircraft,
how can it possibly fund the development and serial production of a sixth-generation Mach 4 near-space interceptor?
Arguably the most complex and expensive combat aircraft ever conceived.
Designed to terrorize Western defense planners and force them to redirect billions of dollars to counter a threat that may never fully materialize.
There is historical precedent for this, and it is a plausible, compelling argument.
The engineering and research, such as the work on combined cycle engines and advanced missile systems, is undoubtedly underway.
Russia has correctly identified the West's strategic center of gravity and its primary vulnerability.
and has publicly declared its intention to build a weapon.
Weapon to exploit them.
The MiG-41, therefore, has already achieved a form of strategic success.
The world must now prepare to counter not just a physical aircraft, but a new and destabilizing idea.
That the high frontier is no longer a sanctuary, and that even the fastest weapons and most critical assets are no longer safe.
The race for the 21st century's ultimate high ground has begun.